Okay, so today we're going to be talking about rectangles. And so with rectangles, um, we are going to learn their properties, okay? Because basically a parallelogram, um, a rectangle is a parallelogram with additional features, okay? So a rectangle is going to be a parallelogram that has four right angles, okay? So opposite sides are parallel. And then also it has four right angles as well. Okay, and so here's the symbol for a rectangle. So wait, what's a parallelogram? Parallelogram is a four-sided figure, quadrilateral, that has both pairs of opposite sides that are parallel. So all these are considered parallelograms. However, um, some of them have more specific names as well. So all of them are parallelograms because opposite sides are parallel. But if you looked at this, you're like, yeah, I know it has opposite sides parallel, but I'm going to call it a square because that's a better name for it. Okay, it is a parallelogram because opposite sides are parallel, but the best name for this would be a square. This right here is a parallelogram because opposite sides are parallel, but I'm going to call it a rectangle. Why? It's the best name you could call for it. Okay. And additionally, this is a parallelogram, but if all four sides are congruent, we're going to call it a rhombus. So just because it is a parallelogram doesn't mean that's the very best name to call it, but it could be true. Okay, I'm a human, but more specifically, I'm a woman. Okay, so the truth is, yeah, there are lots of ways to talk about different people, different shapes, but give them their best name as well. So a rectangle is a parallelogram that has four right angles. So the properties of a rectangle would be parallelogram with four right angles. And so it has parallelograms properties, which means opposite sides are going to be congruent. Okay. This should not be here right now. Okay. Um, and then both pairs of opposite sides are congruent, and opposite sides will also be parallel. So like this side is parallel to that one, and this top is parallel to the bottom. So that's still true because that's what happens with rectangles and with parallelograms. Opposite angles are going to be congruent, and consecutive angles will be supplementary. But in this case, these are kind of weird things to say because in a rectangle, all the angles are 90. So of course, opposite angles will both be 90 and consecutive angles will both be 90 because they both make 180. So these ones are kind of like, they're true, but not the most helpful. The diagonals bisect each other still. And not only do they bisect each other, but notice in a rectangle, there are two additional features. One of them is that all the angles are four right angles, okay? And this should not be here, okay? Um, all four angles are going to be right angles. I just redid my notes this year. I was like, I don't know why that ended up there. So I need to delete that before next year. And then also the diagonals will be congruent to each other. Notice, because it's not just like a parallelogram where the diagonals are one's going to be longer, one's going to be shorter, because it's squared up, okay, or rectangled up, and the diagonals will be congruent to each other. So the length of this one will equal the length of this one. So these are two special features of rectangles that are not features of parallelograms. Okay, so those are additional properties. So the truth is, if you want to say, hey, I've got a parallelogram, is it a rectangle? The two features you can look for would be, are the diagonals going to be congruent? Okay. And so the diagonals are congruent in a rectangle. And so and it goes backwards to say, hey, if the length of this diagonal matches the length of this diagonal, well, then we know we have a rectangle. So here it is. If this is given to be a parallelogram, how do we know it's a parallelogram? The diagonals bisect each other, okay? And if the diagonals are congruent, well, if the diagonals are congruent, then you know that you have a rectangle. So later in the chapter, we're going to be talking about, hey, would this shape be a rectangle? Now, obviously, it doesn't look like a rectangle, but that's how kind of dumb we are in the end of the chapter to say, hey, if I give you 4 points and you connect consecutive points, would that make a trapezoid, a rectangle, a rhombus, a square, a parallelogram, or just a quadrant? What shape would it make? And so if we know that it's a parallelogram, because we remember we talked last time, parallelograms have opposite sides parallel. I'm telling you, this is at least a parallelogram. Opposite sides are parallel. And if you don't believe me, find the slope of each of these lines that are opposite from each other. Find this slope, find the top and the bottom, and you'll see that opposite sides are parallel. So I'm going to say we're going to skip that step on this problem. But if you want to say, hey, if I know, because I found the slopes of all 4 sides, and notice that opposite sides have the same slope. But then the second question is, if it's a parallelogram, how do I know also that it's going to be a rectangle? And the best way to prove that is, are the diagonals lengths equal to each other? Okay, so that's how you show, once you've shown, hey, it's a parallelogram, you show that it's going to be a rectangle by saying, are the diagonals congruent? And so using the distance formula, we're going to find the distance from A to C, and then we're going to find the distance from B to D. Okay, the distance formula, if you recall, is x2 minus x1 squared, and then y2 minus y1 squared. And then add them and then take their square root. So we're going to do A to C. So I'm going to take A with C and find the distance between those points. So I'm going to find the length of that diagonal. So I'm going to do 1 minus 1 squared and 2 minus -4 squared. 1 minus 1 is obviously 0 squared. And then 2 plus 4 is 6 squared. So 0 plus 36, and then we're going to square root it. So the length of A to C is 6 units. And if the length of the other diagonal is also 6 units, then we know that our shape is going to be a rectangle, because I've told you it's a parallelogram because the opposite sides will be parallel if we calculate it. Again, I want to save us some time. And so let's find the distance from B to D. And so we're going to do -2 minus 4 squared, -1 minus -1 squared. That's -6 and squared. That's 36. 1 plus 1, -1 plus 1 is 0 squared. So it's going to be the square root of 36, or 6 units. So yes, it's going to be a rectangle. So the 2 main ways that you show that if you have a parallelogram that's going to be a rectangle is, are the, let's see if I can use whoops, I'm really making a mess. This will actually work. Are the angles 4 right angles, okay? Or are the diagonals congruent? And primarily we'll say, if we've shown the opposite sides are parallel, so it's a parallelogram, we do the second one. Are the diagonals congruent? So there we go. Now let's look at the back of this. Let me see if I can get the page to turn over. Okay, here we go. So the next thing says, given that is a rectangle. So we know it's a rectangle. Use the properties of rectangles to find the missing part. So rectangles have the 2 features of all the angles are right angles, and then also it has a feature of the diagonals are congruent, but then it also retains all the features of a parallelogram. So let's look and see what we're going to do here. Find x and y. Okay, so to find x, notice if the diagonals are congruent, okay, the entire length of each diagonal is congruent, but also the diagonals chop each other in half. So this part matches this part, but because the diagonals are congruent to each other, all 4 of these halves will be congruent to each other because the overall length of each diagonal is equal. Therefore, when they bisect each other, each of those 4 pieces will be equal. Okay, whereas on a parallelogram, the diagonals bisect each other, But on the longer diagonal, those two parts match. On the shorter diagonal, these two parts match, but all four parts do not match unless you have a rectangle. So that's kind of putting a couple things together. So what we can do is we know that 4x plus 15 equals 71. Divide by 4, get x is equal to 14. So not only are the diagonals equal and they bisect each other, therefore all four of those pieces on a rectangle will be congruent to each other. And then to find y, looking at this angle over here, well, if you look at it, these two angles aren't equal to each other. A lot of kids think on a rectangle they're not, that they might be equal. And the truth is they are not. If you kind of want to look at this angle here is going to be across from this shorter side. This angle here is going to be across from a longer side. So therefore, no, because those two sides are not equal in size, these two angles aren't equal, but we do know that's a right angle here. So if you do 2y plus 52, that equals 90 degrees. Okay, so these two little angles here are not equal to each other, but their sum is 90. And so if you had a square, those two angles would be equal to each other. But because it's a rectangle, not a square, then no, they will not be equal to each other. So you minus 52. And then that means that if you divide by 2, you get y is equal to 19. Okay? So those are working with some of these features. The next one says DE. So DE is here, is 3y, and AC is 42. Okay, so in a rectangle, the diagonals are congruent. They also bisect each other. So if you think about it, if this right here is 3y, well, then that means this is 3y. And then the pink one will be equal in length to it. So if you did 3y plus 3y again, you would equal 42. Okay, so the 42 is going to be from A all the way to C. You could also say 3y is equal to 21, and you'd get the same answer. This is 6y is equal to 42, y is equal to 7. You'd get the same answer on the other one. The next part says that find x. Well, how do you do that? Well, the top and the bottom, because it's a parallelogram as well, opposite sides will be congruent. So you know that 2x minus 8 equals x plus 13. Minusing x from both sides will give us x minus 8 equals 13. Add 8 to both sides. You're going to get x equals 21. And if you plugged it in, you would get 42 minus 8. I believe that's 34. And then if you did 21 plus 13, yeah, you'd also get 34 as well. So the top and the bottom would be equal in length. Okay. The next one says, given a rectangle with the following information. And so in rectangle, notice they wrote the word rectangle by making a picture there. From A to E, okay, is 36. Okay. And then C to E is going to be 2x minus 4. Okay, in a parallelogram and in a rectangle, the diagonals get bisected by each other. So 36 equals 2x minus 4. So divide by 2, x equals 20. And then if x is 20, then what would be the length from B to D? Well, B to D is the opposite diagonal, but because it's a rectangle, both diagonals are equal in length. So if you find the length of one diagonal, you can find the length of the other one. And so again, that's not true on a parallelogram, is it? You have a longer one and a shorter one on a parallelogram, but on a rectangle, both diagonals are equal in size. So the truth is, if you plug in x is 20, 2 times 20 minus 4, that is going to be 36, which makes sense. The length of the first diagonal from A to C equals 36 plus 36, that's 72. But guess what? That would also be the length from B to D. There we go. The next one, if BC is 24 and AD is 5y minus 1. So BC is 24 centimeters, and this right here is 5y minus 1. Opposite sides will be congruent, so 24 has to equal 5y minus 1. Divide by 5. Y is equal to 5. Okay, good. Next thing, the measure of AED. So A and then E and then D. That's going to be this angle right here. Remember we talked about you start at A, go to E, go to D, the angle is formed. The middle letter is the vertex of that angle. So this angle is going to be, AED is 12x. This is 12x. And then I say BEC. BEC is here. How come? Start at B, go to E, go to C. That's going to be right here. So that is going to be 10x plus 20. So find the measure of AED. So let's do 12x. They're vertical angles. So if you minus 10x from both sides, get 2x is equal to 20. Divide by 2, you get x equals 10. So if you plug that back in, that means 12 times 10 is 120 degrees. And if you did the same math up here, 10 times 10 is 100 minus or plus 20, this would also be 120 degrees up here. So this angle and this angle are both 120 degrees. Now what they want to know, and this is kind of weird, is they want to know the measure of AED. Oh, we just found it, AED. Okay. Okay, measure of AED is 120 degrees. Okay, cool. Next thing. If AB is equal to 9 and AD is equal to 15, what is A to C? Well, A to C is this diagonal, but we can also, remember the opposite sides are congruent. So if we want to find that, we know it's the right angle. So we can focus on, this is a right triangle. And so you can do 9 squared plus 15 squared equals C squared, the hypotenuse. And so that's going to be 81 plus 225 equals C squared. You do 81 plus 225, you get 306. Take the square root. And so C is equal to the square root of 306. And that's going to be inches. Or if you get a decimal, you're going to get approximately 76.5 inches. So it depends if you use a radical or if you use a decimal, you know, when you take the square root of that. And then the bottom, this is kind of a weird question. If they tell you angle 2 is 50 degrees, and remember we talked about in a rectangle, these two angles here aren't equal to each other because in the triangles they have, the side across from the 50 is longer than the side that's across from this one right here. And so in a rectangle, they don't match, but we do know that this makes 90. So that means that angle 1 is 40 degrees. Okay, so that's going to be an important thing for us to say is like, hey, that's 40 degrees. Why? This angle up here is going to be a right angle. And so if this is 50, this will be 40 so that they can match. And then the next thing we can talk about would be, can we find the other angles that are measured here? Okay, and the answer is, of course we can. And how we can do that would be, look at this triangle right here. This is 90, okay? And in this triangle, if you have 50 and 90, we can find angle 4. And so that is going to be, if you do 90 plus 50, you get 140. So that means this angle right here would be 40 degrees. Okay, so adding 50 with 90, you get 140. Subtract it from 180, you get 40 degrees down here. Now, the other thing that is going on is you have an alternate interior angles. That's an alternate interior angle with this one right here. This angle down here is 90, so this will be 50 degrees. So that's kind of good to know. So kind of knowing what triangle should I look at? Okay, you've got a right triangle here. If the top is 50, the right angle's there, that's going to be 40. And then another thing that we can think about would be, so angle 4 is 40 degrees. Angle 3 is 50 degrees. Okay. And another thing we should think about is down here at the bottom. Okay, I'm going to try to erase some of this stuff. At this bottom triangle, okay, it's a little bit weird to think about, but we have an isosceles triangle because if the diagonals are congruent, all 4 of these pieces are congruent to each other, okay, because they bisect each other and the diagonals are congruent. So if this is an isosceles triangle, well, the base angles will both be the same size. So these will both be 40 degrees. And then also this bottom triangle, if we know 2 of the angles make 80 degrees total, 180 minus 80 means that top angle has to be 100 degrees here because of the triangle sum theorem. And then because this is a linear pair, angle 8 has to be 80 degrees. And then if you look at over here, this is also an isosceles triangle where if this is 50, this has to be 50. Also, the triangle sum theorem says, hey, the sum of them has to be 180 degrees. So angle 7 has to be 50 degrees as well, because it's an isosceles triangle and because of the triangle sum theorem. So as we're doing rectangles, knowing that the diagonals are congruent and that the angles are right will help us to notice that we have some isosceles triangles within there, okay? There's 2 pairs of isosceles triangles within every rectangle, okay? The ones on the side will be congruent to each other. The pink ones and the top and the bottom will also be congruent to each other, okay? Because they're symmetric. All right, well, thank you so much. I hope you have a great day.